all, welcome to EC Electronics. This is a video on digital signal processing exam preparation, and we are seeing the questions from the previous year DSP exams which were asked in the KTU exams happened previously or in the previous years. Okay, so let us see what is the first question for today's class. Obtain the linear convolution from circular convolution for x of n equal to set 1, 2, 3 and h of n equal to set minus 1, 2. There are two steps. In the step 1, what you have to do is you have to make the length of these two sequences equal to L plus M minus 1, where L is the length of your first sequence, M is the length of your second sequence. I hope it is clear. So make the lengths equal to L plus M minus 1. So for this question, your L value is equal to 3, your M value is equal to 2. So 3 plus 2 minus 1, which is equal to 5 minus 1, and the answer is 4. Now, why I am going to convert the length of these two sequences as L plus M minus 1 is because my linear convolution output is having a length of L plus M minus 1. That is, if y of n is my linear convolution output, then y of n is having a length of L plus M minus 1. So, for that purpose, I am going to convert the length of this x of n, also h of n, to L plus M minus 1. Okay, so if I am going to convert x of n to length 4, then how can I convert it? There are 1, 2 and 3. 3 inputs again. So there is a length of 3 already here. So add a 0 to make it of length equal to 4. For h of n, there are 2 inputs or two numbers. So you have to add 2 more zeros. So this is nothing but 0 padding. So in the step 1, what we are doing is 0 padding. Okay. And we are 0 padding to a length of L plus M minus 1. Right. So now you have a new x of n and new h of n. So these two sequences, if you examine, are of length equal. That is equal to length 4. Now in the step 2, what I am going to do is, in step 2, I am going to perform circular convolution. Okay, so in the step 2, I am going to perform circular convolution. So for performing circular convolution, you have two methods. That is concentric circle method and matrix method. You don't have to go for concentric circle method because it is a lengthy process. You can go for matrix method, which is a simple process. Okay, so in step 2, I am going to perform matrix method circular convolution. So I am going to take this as my x of n. So that is my x of n. So I am going to take it and form or do circular convolution using matrix method. 1, 2, 3 and 0. Now how to perform this circular convolution using concentric circle method as well as matrix method, I have explained in my earlier video. So if you have not, you don't have any idea about that, please do watch it. I'll explain here also anyway. So it is 1, 2, 3, 0 is my first column. Now take this 0 to the top and shift these elements to the bottom. So it will be 1, 2 and 3. Okay. Now in the next step, take this 3 to the top and shift these 0, 1, 2 and 3 downwards. So 0, 1 and 2. Okay. So again, take this 2 to the top, then shift all the top elements to the bottom. So 3, 0 and 1. So this is actually your circularly convolved x of n or your shifted x of n. Then take your h of n and perform matrix multiplication. Your h of n is minus 1, 2, 0 and 0. Right. So just do matrix multiplication now. So minus 1 into 1 is minus 1. 0 into 2 is 0. So plus 0, plus 0, plus 0. because these two elements are 0. Now here, this row into this column. I hope matrix multiplication is familiar to everyone. So 2 into minus 1 is minus 2, then plus 2 plus 0 plus 0, because anyway the last two elements will be 0 because here it is 0. Now minus, that is 3 into minus 1 is minus 3, 2 into 2 is 4 plus 0 plus 0. Okay. So for the last row, take this last row, multiply with this column. It is 0 plus 6 plus 0 plus 0. So now the result is, I'm going to write it down. Result is minus 1, minus 2 plus 2 is 0, minus 3 plus 4 is 1, 6. So this is your y of n. Okay. So this y of n is actually your linear convolution output. So have you seen linear convolution anywhere? We have just performed circular convolution, but we have obtained the result of linear convolution, which is having a length of L plus m minus 1 equal to 1, 2, 3, 4. So this is your result. And for doing linear convolution using circular convolution, this methods you have to follow. That is, in step 1, make the length of both your input sequences to L plus m minus 1. In the step 2, perform matrix method circular convolution. That is, here I have done matrix method circular convolution and just obtain the result, and which will be your linear convolution output. And also, if you want to know how to perform or how to do the graphical method linear convolution, I've done a separate video on that, because in some question papers they will be asking how to do the linear convolution of these two sequences. They will be asking specifically, that is, you have to perform linear convolution. So for that, if you want to know, I'll share the link in my description box. Okay, that is graphical method linear convolution. But anyway, in this question, they are asking that to perform linear convolution using circular convolution. So simply by these two steps, you can find the answer. Next question is, having two parts, state the circular frequency shift property of DFT. And in the B part, they are asking 4-point DFT of a signal x of n is set, that is, the signal is given, set ABCD. The DFT is x of k. Find the IDFT of x of k minus 2. Okay, so these two questions are related, and both these questions are based on the circular frequency shift property of DFT. So it is one of the very important DFT properties. So what is actually circular frequency shift stating? That is, if x of n is a original signal, let x of n be your original signal, and let g of n be the shifted version of this signal, and it is defined as g of n is equal to x of n minus m with a period of n. That is, you are going to shift your original x of n by m points to the right. Then you will get this signal. And what is this angular bracket and n denoting? This thing is very much confusing to many of the students. That is why I am explaining. This angular bracket and n denotes that this signal, which is your original signal, is a periodic signal. That is, it is repeating with every n period. That is, after every n, your signal is repeating. That is the meaning of this angular bracket and n. So don't worry about this angular bracket and n. Don't get confused. And what is this n minus m denoting? This is your shifted signal by shifting your n to minus m points to the right. That is, if you shift your original signal x of n to m points towards the right, you will get your x of n minus m. So g of n is actually the shifted version of your signal x of n. Okay, so I hope this much is clear. Now, what is the property stating? So, if DFT of x of n equal to x of k, let the DFT be x of k, of x of n is x of k, then DFT of g of n, that is DFT of G of n is what? X of n minus m, that is the shifted signal, is equal to e raised to minus j 2 pi k m by n into x of k. Okay, so this is your circular frequency shift property. That is, if you are going to shift the original signal by m points towards the right, then there is a exponential term multiplied with your x of k. That is, this exponential term is e raised to minus j 2 pi k m by n, where n is the length of your sequence, that is your input sequence. Then m is the number of points with which the signal is shifted, that is m. See, here is also the signal is shifted by m points, means there is a m here, into your original DFT. So this is how your DFT is going to vary according to the circular frequency shift property. So this is actually circular frequency shift property. Now, so what has been asked in the part 2? The 4-point DFT of a signal x of n is x of k. Find the IDFT of x of k minus 2. So in order to find the IDFT, we don't know what is the value of x of k. But from the x of k minus 2 term, something is familiar with our circular frequency shift property, right? So by seeing such a question, you have to think that it is some property of the DFT. And for k minus 2, such a DFT term, you should know that this is a circular frequency shift property. Okay. So here they are given that x of k minus 2's IDFT we need to find. Okay. So what is actually x of k minus 2? This x of k minus 2 is actually the DFT of your x of n minus m to a period of n. That is, I'm writing the general term here. This x of k minus 2, this capital X of k minus 2 is the DFT of your shifted signal. Okay, here by looking into this x of term, you can identify what is m. M is 2 here. So this x of k minus 2 is actually the DFT of your original signal, which is shifted by 2 points towards the right. Again, if you see the input signal is given, right? The x of n is set A, B, C, D. So what is the period or what is the length of the signal? Length of the signal, n is equal to 4, right? So here it is a 4. So from this question, we can infer these things that x of k minus 2 is actually the DFT of your input signal's shifted version. That is, the input signal is shifted by 2 points towards the right, then we are getting this x of k minus 2. I hope it is clear. So, in order to find the IDFT, that is the IDFT of x of k minus 2 will be what? IDFT of x of k minus 2 will be x of n minus 2. Okay. That is, if you take the DFT of this sequence, you will get this. Then what will be the IDFT of this? Means this original sequence, right? That is, if you are going to take the DFT of our original sequence and then you are getting some sequence, and if you want to find the IDFT of that sequence, that is this x of k minus 2, it will be your original input sequence, right? So the IDFT of this x of k minus 2 is your x of n minus 2. I hope it is clear. So if you practice these type of questions, 1 or 2 questions at least, you will be able to answer this type of question. So I hope this much is clear to everyone. So if you take the IDFT of x of k minus 2, which is your DFT term, you will get your shifted sequence. Now we have only our input original sequence. We don't have the shifted sequence, but we can find the shifted sequence by varying the values of n. So the n value, small n value varies from 0 to 3. That is 0 to n minus 1, right? So n minus 1 means 0 to 4 minus 1, which is 3. So if you vary the n value from 0 to 3, you can actually obtain the IDFT or your shifted sequence. Now I am going to find it. So for that I am just removing this. Okay. So First, I'm going to take my n equal to 0. Okay. So, I'm going to find this shifted sequence, which is the IDFT, right? So, x of n minus 2, x of, here I'm going to put n as 0. So, 0 minus 2, that is x of minus 2. Now, do you know what is the value of x of minus 2? No. Here the time positions are 0, 1, 2 and 3. You don't have the value of minus 2, right? But see the angular bracket. It states that the signal is periodic. So, if the signal is periodic, then x of n is equal to x of n plus n. This is the meaning of periodicity. That is, if your input signal x of n is periodic, means its sequences will repeat with its period. That is x of n equal to x of n plus n. Now, you don't know the value of x of minus 2, but you can find the value of x of minus 2 plus n. Here n value is 4. So, x of minus 2 plus 4 is x of 2. What is the value of x of 2? It is z. So, this is your n equal to 0 value. Okay. Now for n equal to 1, I'm going to find the value of my shifted sequence. Okay, I'm going to call my shifted sequence as y of n. Okay, I'm going to call the shifted sequence, that is x of n minus 2. I'm going to call it as y of n. And I'm going to find the values. So this is my y of 0. Okay, I'll remove these things. So I have obtained my y of 0 as c. Now I'm going to find the value of y of 1. That is, y of 1 is equal to x of 1 minus 2 angular bracket 4. That is, x of 1 minus 2 is minus 1. Minus 1 periodic to n, that is 4. So x of minus 1, 4. Is it known? No, right? So for finding this, I'm going to apply the periodicity property. So minus 1 plus 4 is x of 3. So what is the value of x of 3? It is d. So you got your y of 1 as 3. Now y of 2, that is x of 2 minus 2, that is x of 0, that is equal to a. Okay. Similarly, find the value of y of 3 also. Y of 3 is equal to x of 3 minus 2, that is x of 1. What is the value of x of 1? X of 1 is b. So now you got all the values of your y of n. That is your shifted sequence. I have just called this shifted sequence as y of n. So your original shifted sequence will be set. First value y of 0 is c. C. Then y of 1 is d. Then a and b. So this is your IDFT value. So I hope it is clear. So what we have done actually, in order to find the IDFT of this x of k minus 2, you are given your input sequence. Now you need to find the IDFT of this term. So applying the circular frequency shift property, you can find the shifted sequences. That is the original sequences of this x of k minus 2. That is, if you take the IDFT of the x of k minus 2, you will get the shifted version of this x of n. So for finding that, apply the circular frequency shift property. Find the values for n equal to 0 to 3. So first, substitute the value of n as 0. Then x of 0 minus 2 is x of minus 2. You don't know the value of x of minus 2 because your original sequence is not defined for minus 2. But you know that the signal is periodic. So apply periodicity property, that is minus 2 plus 4, that is x of 2, which is found from your original sequence, which is c. Similarly, find all the values for n equal to 0 to 3. Then you will get your IDFT of x of k minus 2. So this is how you have to do such problem. So these are the questions which I have included in this video. Actually, DSP is very simple if you practice more and more questions. At least if you know that these are the sure questions, there is some areas you will be sure, right? Will be asking in the exam. Then practice at least 2 or 3 problems from those sessions, and then you can attempt your exam very easily. So we'll be seeing with more examples in the upcoming videos. And if you found this video useful for your preparation, please do like it and also share with all your friends who are preparing for DSP exam. And also if you want more videos, please do subscribe to the channel. And if you have any doubts, please do mention in the comment section. We'll do that problems in the upcoming videos. Okay.